So we're going to talk about catalysis or using a catalyst. Again, a catalyst speeds up a reaction. So as you see here, we have our energy profile. It just looks a little bit crazier. You're starting here with our reactants, of course, and we always end with our products. And they're always going to end up left to right like that. And then we have our up that hill like we usually do, where we have to get that energy, that activation energy. And you can see my dotted line over here for my reactants. That activation energy always starts from the reactants. It goes to the top of that hill. Well, this activation energy, the higher one, where you're having to go to this highest amount of energy here, is without a catalyst. Okay, not having a catalyst. It's going to take more energy to activate that reaction. So what actually does a catalyst do? You can actually visually see it here when I go ahead and put in this energy profile. Look where that activation energy went. It's like, wait, I don't have to get as much energy anymore. So my activation energy here is much smaller. And so that is when we have a catalyst. So what does a catalyst do? A catalyst gives you a new pathway. So it creates a new path that you don't have to go quite as high up that hill or climb as high and have as much energy as you did without that catalyst. So it gives you that new pathway. So it's like the roller coaster, if I have to go way, 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 way up, okay, if you give me the next hump, okay, wow, I don't have to go as far. I can do that a lot faster. So that is what happens with a catalyst, all right? Let's see, what else did I need to measure? Oh, if you want to just finish the slide, we have activation into a catalyst, activation without the catalyst, reactants and products. And remember, the enthalpy is always, 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 always the value between the reactants and where the product energy is. It's always between the reactants and products. Just remember that enthalpy change, or that change in energy, or that gives free energy, we have a lot of words for it, can go forward or backward. It is the same value. So if it were 30 kilojoules going forward, it would be negative 30 going backwards. Just change the sign. So that main points there for catalysis. Now, that's probably the extent that'll be on the test. I wouldn't give you something quite as complicated as this, but I wanted to show it to you. Is that question 3 on your worksheet? You actually do not have to fill this one out. I'm going to let this one be an optional question that you can actually do. Later, I'll rewrite this out nicely on a sheet if you want to see it. What we're doing is we are setting the equation that we've learned, and there's two K values or rate constants, one with the catalyst, one without the catalyst. We compare them, and I'm going to show you another version of that we'll do for the Smart Start. And it just shows here what you're figuring out in this problem is saying, okay, if I have a catalyzed or a non-catalyzed reaction, what's the difference in how much faster it goes? So you can see at different temperatures, it's going to change also. So at 25 degrees Celsius, we do all the math here, and it is what, 10 million times faster? I mean, that's a little bit faster. That is like when we did the genie up in the gym, where it was like, okay, all of a sudden the hydrogen peroxide went like 10,000 times faster, and it actually decomposed. At 125 degrees, this one is 180,000 times faster. So you can see kind of the math and worked out, but I just want you to have that idea. The other idea that you want to have with catalyst in your brain is what catalyst in our body, because it's very important to our biological systems. All living organisms, we can't like take us and say, hey, I need to heat myself. No, we're not going to heat ourselves up. So we're going to use what are called enzymes, and enzymes are very well-known catalysts, and they are crucial in speeding up desirable reactions and things that are happening in our body, like keeping our blood pH at a very, very small pH range, and also regulating our temperature to 98.6 Fahrenheit, or at least around there. Not everyone's exactly the same. So we have a lot of things in our body. It's amazing how our bodies work, and those enzymes are number one in helping that happen and keeping things where they need to be. So you can see question 2. You'll also be able to copy that one down later. It's just an individual thing about the substrates of the enzymes. So just some more information for you that's really quite cool. So catalysis really isn't that tough. So let's ask questions tomorrow.